Hello and welcome to the RAIC Corporate Affiliate Series. Our corporate affiliate for today's webinar is VELUX. For over 75 years, the VELUX Group is the world leader in the manufacturing of residential skylights and is one of the strongest international brands in the building materials sector. With over 300 patents in skylight design, VELUX is known for product innovation, quality, and durability. For over a decade, VELUX Canada has been ramping up its commercial product line to serve the Canadian market better. Our commercial program includes the Commercial Sun Tunnel, Tubular Skylight, the revolutionary Dynamic and Energy Dome skylights, and more recently, the VELUX Modular Skylight VMS, a prefabricated modular skylight designed in collaboration with Foster & Partners. VELUX continues to lead the residential industry with the no-leak skylight, sun tunnel skylights, roof windows, as well as a range of blinds, installation solutions, and intelligent home controls. Whether your project is residential or commercial, offer your customers the innovation and quality they deserve at an affordable price. For more information, visit velux.ca/professionals. Today's presentation is titled ICI Skylight Trends Going into 2022, presented by Russell Ibbotson.
Welcome to the webinar. Today I will be speaking about industrial, commercial, institutional skylight trends going into 2022. This presentation will touch on what is influencing the design and specifications of skylights in the ICI sector and where these trends are seen to be emerging from. My team supports a lot of projects across Canada and different applications in the both residential but also the industrial, commercial, and institutional sectors. We get a lot of opportunities to meet with architects and developers and understand what's influencing them and how that in turn is influencing the selections of skylight products and how they're being integrated into the projects. Today's learning objectives, you can read faster than I can speak, so I'll pause for a moment for you to have a look at those, and then we'll move forward. My name is Russell and I'm presenting today. I have about 20 years of experience in the building material sector, and I started in solar energy and was in that sector for 7 or 8 years, switched into Windows for a couple of years, and then I joined VELUX just over almost 11 years ago now. So I spent more than half of my career with VELUX. And at VELUX, I lead a couple of teams. One team is relevant to today's presentation. It's really supporting the commercial business development, supporting architects, developers, and contractors on designing with and specifying the different skylight products that we offer to the market. Some of those you'll see as part of the examples. I've chosen to talk about the trends that we're going to touch on today. So I work for VELUX, and VELUX, we're 80 years old. We're in 40 countries around the world. Our head office is in Denmark. And I only wanted to take a quick minute on this because our purpose is to create well-being for people and planet by transforming spaces using daylight and fresh air. And this sentiment, it's core to the founding of the company 80 years ago. The name VELUX comes from ventilation, and lux is the Latin word for light. So this idea of daylight and fresh air is well ingrained in our company culture. What's a little bit newer is this larger focus on sustainability. And at the time of the recording of this webinar, COP26 is happening. So it's very front of mind for me as I watch as much as I can. And I get ready to make even further changes in my own lifestyle, my family's lifestyle, and thinking about how our industry can make further changes that are needed. I wanted to highlight just a couple of items. This is our 2030 sustainability strategy house, and this has 15 initiatives or objectives that we're working towards. And I wanted to just choose a couple to talk about. Now, first, before I do that, It's Our Nature is how we've named this. And it's got a dual meaning. It's Our Nature touches on the fact that for VELUX as a company, it's our nature to do more. We're in a position where we can and should do more to help our environment. And that's the other side of this. It's our nature is that we have a responsibility to do better by nature and our planet and to look at how we do business and how our business impacts our industry, and what we can do to be leaders and really help us move towards a better climate situation than we're currently facing. So a couple of the key highlights I wanted to touch on that are in line with this. Um, we're working towards being carbon neutral by 2030, and this is going to be a combination of converting energy to renewable energies, and looking how we can reduce. So part of this is actually reducing the carbon footprint of our product by 50%. So we're not just offsetting the carbon we produce, we're looking at producing less carbon and less carbon going into our product. And we're looking at this as part of our value chain. So looking at our suppliers, currently only 6% of our carbon footprint comes from our production. The other 94% comes from our suppliers of glass, aluminum, plastic, and wood. And so to get to 50%, we've got to work with our suppliers. We've got to be creative on design, product selection, and really help our suppliers find cleaner ways to make the materials that we're working with. And this is working towards the big, I'll say, the goal that made the hair on the back of my neck stand up. By our 100th anniversary in 2041, we're working towards being lifetime carbon neutral. So the entire current 80 years and the next 20 years of our company's existence, all that carbon will be offset, and it'll be offset in partnership with the WWF. This is a group that knows where to protect and nurture forests. So we want to look at how do we have a real impact on nature, and ensure that our activities, and the benefits from our activities and some of the financial benefits from our activities are also going to have a beneficial impact on our planet. So this is something at VELUX that we're extremely passionate about. This is more than a year we've had this in place, but a lot of the details are still being unfolded at this time. Just quickly, for example, how to promote a circular economy. This is very challenging, and we're hoping in 2022 we're going to have some clearer pathways forward on that. So perhaps if you're interested, you can check our website, and I expect that next year I'll be able to talk a lot more about some of these initiatives. With that said, and it was really important, I felt importance in being able to state that before we started. I'm ready to start the presentation. So we're going to talk about trends, and we're talking about trends for skylights. And I've never done a trend discussion before. We're recording two as part of this series. One's residential, and one is for ICI, again, industrial, commercial, institutional. And this is the latter one. But we've always talked about this within our support group, our project group that's working with architects and developers all the time. And it was the first time we had to actually think about how do we pull this together. So this is our first attempt, and it's pretty good. I think next time around it'll be even stronger. The first thing I want to talk about is diffuse light. So this is light that doesn't have glare. This is that even distribution of light that you might get on an overcast day, that sort of thing. And kind of a subsector of diffuse light is north light. We're going to take a little deeper dive into that because I think there's some interesting stuff, trends happening that we're seeing in the Canadian market in this area. We're talking about Get Smart, and I've been vague about this, but it's going to cover a couple of categories that we've labeled as smart. And then part of that, kind of a subcategory of getting smart, is blinds. So it's going to be closely associated, but I've pulled it out like Northlight. I pulled blinds out so that we can have a deeper discussion on what their impact is. And upgrading. We have a lot of existing buildings, and we have existing buildings that are being repurposed, and we have existing buildings that need to be upgraded, and that's having a big impact on skylights. So let's spend a few minutes to talk about some of the things that are influencing the skylight selection and specification in this sector today. And then once we go through this list, I'll dive into the 5 key trends that I've identified. So the first one is climate change. And we're working and we're looking at how we can improve our impact and kind of reduce the impact of what climate change is going to have on our communities across Canada but the trend is that we're warming up, and we're already seeing more extreme weather conditions. So this infographic, I've seen it in a couple of presentations, and it really captures that, that idea that we're going to have more heat waves, longer heat waves. We're going to have more extreme temperatures and more extreme rainfall. And this is having an influence on our discussion about skylights. Because this is something that all buildings, when we're looking at durability of the building and we're looking at the comfort of the people in the building, and then the impact of building and operating that building on the world or on our environment, this is becoming a driving force. So we're going to touch a little bit in a couple of areas on how this is influencing the trends. And of course, the carbon, looking at how we're selecting products, and we're trying to get to a 50% carbon footprint on our product. But we also have to look at the operational carbon. So skylights, like other types of fenestration, they have an energy balance, and you try to minimize the energy loss through the skylight, or the energy required for cooling in the summertime. And skylights, because we have such an increased exposure to the sun, we have to be even smarter about our use and selecting products and specifying those for projects. So skylights become particularly impacted by this need for being more conscious and careful with our operational carbon. So we're going to touch a little bit on that as well. And energy codes. We've got the new building code is going to be coming out later this year. But the National Energy Code for Canada for buildings, we've got a couple of versions that are currently in provincial codes. And I'll say the 2017 version, one of the big changes for skylights is that it went from 5% roof area down to 3% roof area. So if you were doing a commercial building, and we're limited to 3% under the prescriptive path, you would be able to do roughly the amount of daylighting level, or the light levels you would need for like a warehouse application. If you were doing something that required a higher degree of daylighting, then you would either have to reduce the area of the building that you're going to provide daylight to, or go with a performance model. So I understand the motivation of this is to reduce the energy of the buildings, but there are other things that can be done. So I'm hoping that we're going to be in a position to support those performance models so that we can look at how to be most energy efficient with the use of skylights. We've also seen an increase interest in the indoor environment, and I'm showing some HEPA filters, but the discussion around ventilation and filtration, although it's been maturing in recent years, I would say that the discussion about COVID being airborne has thrown it in high gear. And as we start to look at returning back to work and the use of spaces, the idea of filtration and ventilation is becoming much more mainstream. And because operable skylights can be used for natural ventilation, this is starting to impact the discussion on how can we use skylights as part of our indoor air quality or indoor environment design plan. Now with skylights, you can get up to 2 times the amount of daylight through a skylight as you can through a vertical window, just because of the simple placement on the roof. But this also means that you have that risk of glare. And glare is really the contrast between bright and not so bright that you may experience when you have direct light coming through a fenestration product. So this is having some influence because the comfort of the space is really important. Now, when you get 2 times more daylight through a skylight, you also run the risk of getting 2 times more solar heat gain through that skylight. And I did a webinar last year that talked about energy, and we really dug into the numbers on this. We don't have time today to look at that, but solar heat gain really is the amount of the heat coming from the sun that's actually getting through the glass into the building. This could be beneficial in the wintertime, but in the summertime, it can greatly increase your need for air conditioning. And that becomes a concern when we're trying to reduce the energy use and in turn, the carbon footprint of operating the building. So we need to be a lot more smart about how we're using and specifying glazing. Last point on this, as we build more and more energy efficient buildings and we build towards, I'm an engineer, so programs like net zero and passive house and these other, high performance super buildings, we have to acknowledge that they're at an increased risk of overheating because they don't have the same systems in place or the same, I guess, tolerance of overheating. So all of a sudden, as we build these super buildings, which I think is we need to go in that direction. But we also need to think about, well, how are we going to make sure that we're not risking overheating, because that's going to be a risk if we have to be able to stay in place in a heat wave, perhaps even without electricity to provide air conditioning. Views are a big deal when it comes to skylights, raising the ceiling, extending the view out to the sky. It's one of my favorite things about skylights and why I have 7 of them in my own house. It's because this is something that is just, when you're in a space, and if most of the windows in my own home and even my office, they look out, and I don't get a sky view unless I'm close to the window. But being able to look up and seeing what the weather looks like, seeing the conditions, the sky conditions changing, the sun changing, there's a real connectivity to nature with that. And that discussion has come in a lot. And I can contrast that with the diffuse light discussion, because a lot of the products that provide diffuse daylight, you lose the view with that. So that's going to be coming up. And finally, before we move forward, is this need for upgrades. We have a lot of existing buildings with very poor energy efficient products on there. So this need for upgrades, which can be for energy performance, it can be for improving the daylight quality. It could also be for safety. And we're going to end it on that, on a discussion about upgrades on buildings and their skylights and how that trend is emerging. So there's a lot to consider, and when you're looking at any building design, not just the skylight component of it, you've got to think about how to balance this, the impact of the climate, the carbon footprint, that's on the planet, and think about how are we going to impact the people that are in these buildings. Is it going to be comfortable and healthy for them? And what cost is that going to be? If we're going with smart systems, automated systems, how do we balance all of this to make sure that we have a good skylight experience? All right, we named the 5 earlier, so let's jump into the first one, diffuse light. So the first application I'm looking at is what the building code calls a tubular daylighting device. Our product name is Sun Tunnel, and there's a couple of other products in the market, but really what you're looking at doing is bringing daylight through an aperture at the roof and reflecting that daylight down through a highly reflective tunnel. And these tunnels, depending on the angle the light's hitting it, are 97 to 98% reflective. So highly reflective. And then at the bottom of the tunnel, having a diffuser that's going to spread the light evenly through, coming out of that product. So I chose this product because it's rather large, or this project, it's large in scale. It's in China, and it's, I guess, a basketball court. So you can see there's the series. It looks a bit Star Wars-like, but there's a series of these commercial sun tunnels, or tubular daylighting devices on there. And you can see from this image that there are actually no electric lights on in this space. This space is being lit by these 54 tubular daylighting devices. And you're getting this nice even distribution, nicely colored because it's daylight, so you're getting more full spectrum color coming into this space. So it's a neat project. Another product category is the dome type skylights. And historically, these would be clear or bronze, and bronze was often to reduce solar heat gain. This design, or this product category, has matured quite a bit in recent years. We've seen an increase in use in prismatic diffusers. So prismatic being very similar to what you might have in a drop ceiling. It allows the light to spread, and you get an even distribution of highly diffuse light. The structure you see, the kind of turtle shell shape of that is to give the product structure. So in Canada, when we have snow considerations, that comes into play. Now, the other element I'll point out, because this is the energy efficiency side, historically, these plastic domes are 4 times less efficient than a glass skylight. But we now have technology where we can put in this case, it's a multi-wall polycarbonate panel with Lumera aerogel in it. So we're able to greatly increase the performance of a product like this, more for retail and warehouse type applications, but we can get very good U values or thermal efficiency values, and we can look at how do we get better solar heat gain values. So this is an example. I like this image because it's showing kind of before and after the skylights installed. So if you look along the right-hand side in the ceiling, those skylights are installed. You don't see any hot spots or the spotlight on the floor of this warehouse facility. And I believe this one is in California. If you look a little bit more to the left where they haven't finished the ceiling, you can see there's 2 spotlights on the floor, or hot spots. That's where the skylight hasn't been installed yet. So, but when you put this skylight on, it creates that more even distribution of light. The tubular daylighting device would have a similar effect with that. And you get this nice even distribution of light that's going to be very comfortable in the space. We don't offer this product in Canada, but we do in the US. This is a semi-transparent panel, and this could be used both on the roof or in vertical applications. There are other suppliers of similar products. And you can change the U value with this product so that you can, if you increase the thermal efficiency, you're simply reducing the amount of light transmittance that's coming through this product. So there are a lot of applications where a view is not necessary, but you want to bring in even daylight. So that's an option you can look at. And we're probably a couple of years out before we'll be offering this product in Canada, but it's something that we're watching very closely. This is a project, this is actually a library in Belgium, and I've shown the roof image on the right because they have a light filtering exterior blind on this skylight. So they're using blinds to create this highly diffuse light on the days where they have direct light. So they can open the blind when it's an overcast day, and if you spent much time in Western Europe, you tend to get a fair few of those. So on an overcast day, they could optimize the daylighting by having the blinds open. On those clear sky days where you might get direct light, which might cause some discomfort with glare, they can close those blinds. I'm not sure if this project is using sensors or whether it's just operated by somebody that's involved with the operations of the space. But certainly that could be an option, is to add sensors to operate those blinds. The last one I'll talk about on diffuse light, and I'll transition into the next one, which is north light, is the use of skylights facing north. And since it's the next topic, I'll jump right into it. This application of facing sloped glazing towards the north really became popular during the Industrial Revolution, and particularly in Europe. We see a lot of European manufacturing facilities that had this design in place. And at that time, it was primarily to bring in that even distribution of daylight. When you are in the northern hemisphere, which Canada is, and Europe, the sun travels from east to west across the southern sky. Now, in the summertime, you get a little bit of time where the sun is towards the north in the morning and in the afternoon, or in the late day, I guess. But you're going to have very little direct light that's going to penetrate into those skylights. And those skylights typically are positioned at 60 degrees, as that's the steepest you can take a skylight in the Canadian Building Code and still be considered a skylight. So once you go past 60 degrees, it comes into your vertical window calculations. So if you tune into the residential one, that becomes key when you're looking at your window ratios, because the skylight 60 degrees and below doesn't factor into that. Doesn't always impact projects the same in the ICI side of things, but it does come up in conversation, and in some cases is worth considering. So here are a couple of examples. This is an office on the left there and a school on the right. These are both in Europe where they're using the product. So you can see you can have quite high ceilings, or you can bring your ceilings rather low and use this Northlight application. Now this is an interesting project in Switzerland where they actually added an additional floor to this building as part of a renovation, and they added these north-facing skylights to bring in that even distribution of light. And here's a picture of the interior of that office space. You can see you get that nice reflected light coming off of the sloped backside of the light shaft. So you get this nice distribution of light. And if you look closely, the shadows are not very heavy in this space. So you get a nice comfortable set of comfortable light. Now, I did include the other pictures because in Canada, we get a fair bit of snow, and in Zurich, they get snow as well, but we're always sensitive to that here. You can see that they've created some large drainage channels between those troughs on the sawtooth. So it's often referred to as a sawtooth when these north lights are close together for obvious reasons. But there's a particular interest in how do we get the drainage of snow and potential ice buildup out of that space. So we've looked at that pretty closely. Now, bring it closer to home. This is an exciting project that's in construction right now. This is the Niagara Falls Exchange project by DTAH. And this project is replacing a farmer's market with a community center that's going to have a farmer's market, an artist studio, and it's really multifunctional community space. So we're really excited to work with this architect firm for a couple of years, working towards this design and supporting them and realizing their vision for the project. There's a couple of indoor renderings, and I'll point out that because these are facing north, the renderings are a little inaccurate because you wouldn't have the hotspots or spotlights from the skylights on the wall or floor. It would be just diffuse light coming into this space. But it's I know artistically it looks more interesting when you can present skylights in that way. We certainly have a lot of photography in our marketing catalog that promotes that that visual because it is of interest, and especially when you get to spend time in those spaces because that light changes over the day and over the year, as the path of the sun changes. So this picture was taken, I think, a couple weeks ago now. So they're on track. They've got the wood decking up, and if you look closely, there's the little slots between the roof decks. That's where the skylights will be positioned, and those skylights are in transit for the project now. Another project that we're very excited to be involved with is going to be starting the tender process soon. You can see in this application, they've stretched out the sawtooth design. So the application wouldn't require as much daylighting, being a wastewater treatment facility, but Acre Architects has less rows of skylights and able to create this high quality daylighting. I'm going to be there next summer for vacation, so I'm hoping to be able to see this site under construction at that time. All right, moving on, we're going to take a look at Get Smart. And as I mentioned, I wanted to touch on a couple of elements for Getting Smart, because I think for me, this really Getting Smart is this combination of understanding the potential of skylights and the application of skylights in more detail, but also looking at how can you automate the use of skylights. And I think there's this duality for me that they overlap. So that's why we group them together. So the first thing I want to talk about is that skylights can aid in optimizing indoor climate. And I'll get into that because there's a couple of elements that play into that. But I want to start by stating that the commercial buildings today are using 15 to 20% of the world's energy. So being able to reduce the energy of these types of buildings while improving the indoor climate becomes a very interesting challenge. And the IEA had a couple of interesting numbers that I'll reference. They said that natural ventilation can reduce air conditioning energy by 30 to 50%. So there are times where air conditioning perhaps wouldn't be needed if well-designed natural ventilation was in place. And we've seen a much bigger interest in this. There's still a need for additional expertise. And I'll say this is an area that internationally, the VELUX commercial group is looking at. How can we build additional expertise in this area so that we can better support design teams that want to work with natural ventilation in the project. And the last IEA number is that daylight can reduce lighting energy consumption by 50%. And of course, this has a lot of consideration on the building typology, the use of the building, but it's something that certainly we can be doing a better job with in many projects. So on the getting smart side and looking at indoor climate, I'm going to take a couple of slides to talk about natural ventilation. And skylights become really interesting with natural ventilation because natural ventilation is driven by a pressure difference between the inside of the building and the outside of the building. And the primary pressure difference outside of wind would be temperature. And the higher that you have, the greater distance between your openings. So in the image I'm showing here, a vertical opening and the skylight's opening at the top, the greater that distance, the greater the stack effect. So this idea that hot air rises. So you'll have more airflow if you have your two openings at a difference in height. So skylights become very interesting when you're trying to optimize natural ventilation. And then we have the use of blinds. And I'm going to talk more about blinds in the next section because they kind of deserve to have a standalone, because blinds really have dual purpose when I think about them. The first one is comfort, and it's controlling light. And the second one is controlling the heat gain and potentially the heat loss as well in the skylights. So I'm going to touch a little bit more on that later, but they become really important. Now, the one thing with this type of product use is that studies show us people are not good sensors. They're not good at they might be good. Hey, there's a glare. I'm going to close the curtains or the blinds. They're not good at going back and opening them back up. And they may be slow to react. If we're looking at the thermal discomfort, sometimes that thermal discomfort, if the temperature is changing slowly, we're slow to react. So the use of sensors and the use of combining natural ventilation in a hybrid way with mechanical ventilation is what's going to be needed to really optimize this. So we've got to get a little bit smarter around that. So the project example, this is an office space that is in the UK. They're using natural ventilation. It's a little misleading when you look at the roof here because there's a mix of photovoltaics and skylights. But if you see the interior shot of that center corridor, you can see that the skylights are prominent along there. Now those skylights do operate, they open up, and they allow for fresh air to flow through. And the vertical windows in each of the 3 floors of the office spaces are able to open up. So if you wanted some more fresh air and it was the outdoor climate was appropriate, you could open up your window and allow for some air to flow through your office space. And in Europe, they're much better at just doing short airings. And it's not something that we're familiar with as much in North America, in my experience. But the idea of 5 or 10 or even 15 minutes of opening up the windows to just get that flush of fresh air through. And what I've noticed when I do it in my own home, even in the colder days, it doesn't have that big of an impact on temperature or humidity. It has a surprisingly great impact on the CO2. So when we breathe out CO2, and so by bringing in even just a burst of fresh air, we can greatly have an improvement of the CO2. So this project is leveraging that, and it's something we're very excited about, and we're looking to build our resources to better support that. So when you're using venting skylights are going to be able to open and close. Most of the time now we're looking at ones that are electrically operated, so they can be connected to automation or to switches. And we do that both in the ICI sector as well as the residential sector. And I know 4 of the skylights in my own home are connected to sensors measuring CO2, humidity, and temperature. And the blinds and skylights have some functionality based on what's happening in the indoor climate of my space. And it's using this system, sorry. So this is a residential system, but we certainly are tying into commercial sensors, commercial or systems that are building automation. and more so tying into the HVAC mechanical setup. So if you're getting sufficient air quality through natural ventilation, you don't necessarily have to run the mechanical ventilation. Now that's a little bit more sophisticated than we're typically used to doing in projects. So we're looking at how we can better support that to make sure that we're meeting all the health and safety requirements of a space. Now, another element of getting smarter is having smarter design. And we've seen the rise of use of the daylight factor for some time, and now more recently looking at the daylight autonomy and this ability to be able to predict how much daylight we're going to get. So as we build these models and we're building more intelligent models with BIM in them, we can start playing around and iterate and take a look at what's the energy impact of having these skylights. What's the energy or what's the indoor climate impact? So we can run hourly models on indoor climate. What's the impact of being able to operate the skylights during these conditions? Those parameters can now be put into the computer models, and you can get estimates on what that energy impact is of the skylights. So you can start playing around with, well, how many skylights do I need in this application? How many, am I getting the daylight and fresh air requirements that I want? So that's taking place now. It's something that I'm working with my team to be better positioned to support projects on. And just to give you a rendering of the project we just saw the daylight model for. Okay, jumping forward. Blinds, I touched on it briefly. Interior blinds are really good at controlling light. And you can have them from just light filtering to room darkening. I have them over top of my bed. I'm in my bedroom now. If the camera's on, you can see. You can block most of the light if necessary, but they are good for light filtering on those sunny days, like we saw in that library in Belgium. Now, interior blinds do have the ability to reduce the solar heat gain coefficient. So it can reduce the solar heat gain, and our studies on a residential product show it to be a reduction of about 50%. And you can improve the U value, so the thermal efficiency a little bit, by having that blind in the closed position. So blinds can help on the energy efficiency. It also helps on the comfort if you need to reduce the amount of light. Let that little video play quickly. All right. Now, exterior blinds are really interesting. And in Europe, we have awnings and shutters and exterior blinds. We have these different product categories. And they become interesting for a couple of reasons, because in the summertime, with an exterior awning or blind, you can reduce the solar heat gain significantly. So what we see in Europe is they tend to go with a higher solar heat gain glass and then have blinds to use on the very sunny days. So over the year, the energy balance of the skylights is better. Where in North America, we tend to use low solar heat gain glass in our skylights, and then because we're not using exterior blinds. So we're going to have a worse off energy balance over the year. So I really like this approach. I also think that exterior blinds are good for reducing sound. If you have any sound like rain, it's going to reduce the sound for that. The big concern though, and as we start to look at least in our residential category, bringing blinds to the North American market, or exterior blinds to the North American market, is that, how are they going to react in the winter, in the snow? So this we'll have to develop a robust product for the Canadian climate, but that's something that's in discussion now. Now, the other part of it on the energy efficiency side is that in the wintertime, when we have those clear nights, an exterior blind would improve the energy loss or reduce the energy loss from that clear sky. So, on a clear night in the wintertime, you can get a frost when it's not below zero. That's because we're radiating heat out to really space, and space is cold. So skylights facing the sky do risk having an increased heat loss on a cold, clear night in the wintertime. So if we're able to build an exterior blind that's robust enough to operate in the winter, and we're not worried about ice and snow, you'd be able to close those and further improve the energy efficiency of the skylight. We have these for our residential products. This is a European example of an awning where they might use it seasonally. to reduce the solar heat gain. And hopefully that'll be coming into our product mix for North America in the next couple of years. Another option for changing the amount of light and the amount of heat gain through the glass is using electrochromatic glass. There's a couple of suppliers. We've teamed up with one particular supplier. We're not doing this on a lot of projects, but it's certainly coming up on some projects. And it's an interesting way to control the light and solar heat gain on those very sunny days. Now, it's also a nice example to be able to talk about when you reduce the solar heat gain on glass. It usually means that you're adding some coatings or layers of tint. So you're losing out on you're reducing your color rendering index of the light coming through the skylight. It's also going to reduce the amount of light. So the amount of light transmission you can see here goes from 79% to 50% to 1%. This is a pretty extreme spread. But even when you're selecting the glass for a project, there are going to be a reduction of light transmittance based on the types of coatings and number of panes you're putting into it. So that's something to keep in mind as part of that trade-off when you're looking at selecting more energy efficient glazing. There is a backside of that where you're losing some quality of view, some quality of light as you move towards more energy efficiency. So the last one in this category, I wanted to touch on the tubular daylighting device. Dampers are used within the tunnel. So the damper is close to the diffuser at the bottom that we talked about earlier. And this is a project, a school that I visited a few years ago now, where this school, I went in a month after it had opened, a new school, happened to be there, had to go after school, so it was later in the afternoon. And I was able to take a couple of light meter ratings. This was just an app on my phone at the time. I didn't have my handheld meter with me, but you can see that with the dampers open, we had a lux level of 248, which roughly be about 2.5% daylight factor. And then with the dampers closed, the rating went, or the lux level went down to 14. So in an application like a gymnasium where you also have a performance stage, you could shut off the daylight in order to have a production on the stage. And similarly with some of the other products, you could use blinds to achieve this objective. All right, so now we're going into the last section, upgrades, which is going to have a couple of different angles that I'll touch on as we go through. So this was a project from a few years ago. This was at Cornell University, and they replaced an existing skylight that was leaking, that was really not energy efficient, that looked bad with one of our product lines, the modular skylight. And this is something we've seen quite a bit of because there's a lot of buildings in place that have old skylights that have issues. That's a great opportunity to come in and do a much more energy efficient product. That I'm not sure, but that's likely that was a single glazed skylight system, and they can come in and do a triple glazed skylight system. I don't see blinds on this application, but that would be an option to further improve the energy efficiency. And you can see there are some operable, so that there is ventilation available in this application, which is really nice for those nice days. Now, this is an elementary school in New Brunswick. So this was an interesting project because initially the architect was going to replace like for like. So these barrel domes with the crossbars on them, they were just looking to put new skylights on, replace like for like, just because these ones were old and they were starting to have some issues. And we got involved, and we actually were talking to our sister company in the US that provides a product like this. And in the process, we determined that the slope that they were on, it wasn't advisable. So we started looking at what our other options were, and the modular skylight system that we bring in from Denmark ended up becoming a very good option, and price-wise was actually a little bit less expensive for the installation. There were a number of factors that played into that, but essentially they ended up with a skylight system that was 4 times more efficient, but had a comparable cost. I don't know how often that would happen, but certainly it was an interesting case. So we're really happy to have that project forward. And I think I know they made a short marketing video from this project. If you're interested, you can reach out to me. I can share that with you. This is a project in Vernon, British Columbia. So this project had 4 large skylight systems in place. I think the one there is approximately 22 by 24 feet or so, with the 3 barrel domes side by side. Similar situation, they were starting to have issues with the product. It was time to replace it, and we were contacted, and we went with a step system. So again, probably in the 4 times more energy efficient application. And they were able to upgrade to much more energy efficient, and they've since added blinds or they're in the process of adding blinds to help control the light when it is very sunny, because they're getting more light through this product. But it's something they're very happy with. They did 2. This was my last plane trip just before the pandemic hit, and they're planning on doing the other 2 skylights when they can. The interior shot kind of before and after. So visually, even though you have the stepped up skylight to allow for drainage with the modular skylight, you can see from the interior that visually it doesn't have a big impact on the system. Now, sometimes upgrading doesn't mean replacing a skylight, but adding a skylight. So this was an office space for a retailer headquartered in Montreal. And in this space, they had this central area that had no access to vertical windows. So it was devoid of daylight, and they were able to come in and put in this high performance skylight to really create this special place. And I think seeing the tree in the middle really exemplifies that this feels like, it gives you that outdoor feeling. You got the view of the sky and a bit of greenery there. So you can use skylights to upgrade existing spaces in that way. Now, the last couple projects I want to touch on are more of the repurposing applications. So taking an old warehouse or factory and updating it is what happened in this project. This is in Chicago, where they took an old building, and you can see the L train in front of the building. And they use skylights as one of those central design features to bring ample amounts of daylight into this space. And you can see they've even got interior glazing overlooking this atrium element of the building. So even though the building's not huge, it's got this really strong connection to all this daylight coming in from above. Now, closer to home, a couple of years ago, we worked with LGA architects on the Evergreen Brickworks and on this building, and you can see that the skylights are installed, and they've had some events below there. And this was really, we had this large footprint building, and there was a lot of work done. And I love this space because it's this interesting balance of preserving the history, acknowledging the different stages that this site had over time, but also trying to figure out how to repurpose it and making it a valuable asset to the community. So it's a really nice mix. And the skylights were brought in to bring some more daylight into this space because of the size of the floor plan. So we're seeing this trend of reusing spaces and repurposing spaces, and skylights are becoming a bigger part of that. Because skylights are bringing daylight in from above, they can bring daylight deeper into a building than vertical glazing can. So that's something that we're seeing a lot more interest in. Final thing I'll touch on, just because I've slipped it in as part of the upgrade, there's an increased interest in safety around skylights, safety on roofs in general. And skylights by code are considered an unprotected opening in the roof, unless you can have somebody sign off, an engineer sign off that that skylight would be safe if somebody fell on it. So what we're seeing is an increased requirement for an external screen, what we're seeing here, but also internal screens in case somebody was to come through that skylight. And I'll say that the materials that we're using in this type of skylight today are much stronger and thicker and better tested and time tested. So when we do the heat cycling than skylights of the past. So I'm less concerned about the skylights that are being installed today than I am about skylights that were installed in some cases 4 or 5 decades ago. Those skylights I'd be very nervous around because that material has been degraded by the sun and temperature cycles. So those ones in particular, we've got to be considerate of. So there's an increased interest and I would say a trend around how do we protect new skylights, but also existing skylights on buildings. Okay, that was the top 5 trends for skylights going into 2022. If you have any questions or would like to discuss this further, feel free to reach out to me. And hopefully I've covered off the learning outcomes of today's presentation. And I wish to thank you for your time. Thank you for sticking with me to the end of this presentation. And please check out the RAIC YouTube channel. We have other content that we've put together in collaboration with the RAIC. So thank you very much for your time.
Thank you. For more continuing education opportunities, please visit the RAIC website at raic.org/continuing education.